Look at this. It's flawless, brilliant, and arguably the most coveted gemstone on planet Earth. For centuries, we've associated diamonds with luxury, romance, and eternal love. But science tells a much more violent, ancient, and mind-blowing story. Every single natural diamond on your finger or in a museum is a survivor. It survived billions of years trapped in a subterranean hellscape of crushing pressure and scorching heat. Today, we are going on a journey 100 miles beneath the surface to uncover the epic biography of a diamond. We'll look at the cosmic recipe required to make them, the volcanic superhighways that brought them to us, and how you can spot the difference between nature's billion-year miracle and a modern lab-grown twin. If you think a diamond is just squeezed coal, prepare to have your mind completely changed. Let's dive deep. The anatomy of carbon. To understand a diamond, we have to talk about its sole ingredient, carbon. Carbon is the ultimate shapeshifter of the periodic table. It's the basis of all organic life, the graphite in your pencil, and the sparkle in a diamond. So, how can the exact same element be so soft that it rubs off on paper as graphite, yet so incredibly hard that it can slice through steel as a diamond? The secret lies in the handshake between the atoms, what scientists call allotropy. In graphite, carbon atoms are arranged in flat, two-dimensional sheets. They slide over one another easily, like a deck of playing cards. But under the right conditions, those atoms are forced into a rigid, three-dimensional pyramid structure called a covalent tetrahedral lattice. Every single carbon atom bonds tightly to four others in all directions. It is the tightest atomic packing found in nature. But nature doesn't just hand out this structure for free. It requires an environment so extreme, it doesn't exist anywhere near the surface of the Earth. The deep Earth kitchen. Forget the myth you heard in school, diamonds do not come from coal. Coal is made from dead plants and is found in the Earth's crust. Natural diamonds are much, much older than the first land plants. They are born way deeper, in the mantle, roughly 90 to 150 miles, 150 to 250 kilometers, beneath our feet. Scientists call this specific boundary the diamond stability zone, located right beneath the oldest, most stable parts of continental tectonic plates, known as cratons. To bake a diamond in this deep Earth kitchen, you need a very precise, terrifying recipe.
Extreme temperature, between 1050 and 1300 degrees Celsius. If it gets too hot, the carbon melts into magma. If it's too cool, it stays as graphite, crushing pressure, about 45 to 60 kilobars. That is roughly 50,000 to 60,000 times the atmospheric pressure at sea level. Imagine balancing the weight of the entire Eiffel Tower on the tip of your thumb. That is the kind of pressure we are talking about. Under this unimaginable weight, carbon atoms have no choice but to lock arms into that indestructible diamond lattice. And then, they wait. For hundreds of millions, sometimes billions of years, these diamonds sit in absolute darkness. The Volcanic Express. So, if diamonds are trapped 100 miles underground, how did they get into our jewelry stores? They didn't walk up, and we certainly didn't dig that deep. The deepest human mine is a mere 2.5 miles deep. Think of these as the ancient, supersonic elevators of the geological world. Kimberlite is a rare type of volcanic rock rich in magnesium and iron. Every now and then, and by now and then, I mean hundreds of millions of years ago, deep-seated magma chambers would suffer a catastrophic buildup of gas, triggering a violent, supersonic eruption. These eruptions didn't ooze like Hawaiian lava. They blasted through the crust at speeds approaching Mach 2, tearing off chunks of the mantle along the way. These ancient volcanic pathways are called Kimberlite pipes, named after Kimberley, South Africa, where they were first heavily discovered. The diamonds were essentially passengers inside this volcanic rock. The trip to the surface had to be fast. If the magma cooled too slowly on the way up, the changing pressure would cause the diamonds to literally transform back into worthless graphite. The rapid cooling locked the diamond structure in place forever. Nature versus lab diamond. Today, humans have figured out how to replicate the deep Earth kitchen. By using two main methods, HPHT, high pressure high temperature, which mimics the Earth's mantle, and CVD, chemical vapor deposition, which grows diamonds atom by atom from a hydrocarbon gas cloud, we can create diamonds in a matter of weeks. Here is the mind-blowing part: lab-grown diamonds are chemically, physically, and optically identical to natural diamonds. They are not fake. They aren't cubic zirconia or moissanite. They are pure carbon lattices. So, how do experts tell them apart? Nature leaves inclusion gems, tiny imperfections. Natural diamonds often trap tiny bits of other minerals, like garnet or olivine, inside them as they form. These are the birthmarks of nature. Lab diamonds, on the other hand, are often too perfect, or they display specific microscopic growth patterns that only specialized UV light machines can detect. While a natural diamond carries the romance of a billion-year-old history, lab diamonds offer a flawless, more affordable modern alternative. From an ordinary carbon atom trapped in the crushing, molten depths of the ancient Earth, blasted to the surface by supersonic volcanoes, to a sparkling masterpiece cut by human hands, the journey of a diamond is nothing short of miraculous. The next time you look at a diamond, don't just see luxury. See a tiny, indestructible piece of Earth's deepest history that survived the impossible just to shine in the light. What do you think? Would you prefer a natural diamond with a billion years of history, or a scientifically flawless lab-grown diamond? Let me know in the comments below. Don't forget to hit that like button, subscribe for more deep-dive science stories, and spin the notification bell. Until next time, keep exploring the hidden wonders of our world.